Hello, grade 12. Let's do a question, another question on vertical projectile motion. Okay? This question states, a man standing on the top of a building dropped a tennis ball and observed the motion of it during 6 seconds. When the man catches it again, the velocity times graph below describes the movement of the bouncing ball during 6 seconds. Ignore a resistance. And this is the graph that we are working with. Okay, so let's go to the question again. Say a man standing on the top of a building dropped a tennis ball. Okay, so the ball is being dropped. This is an important data here because that means that the initial velocity of the ball is 0. So in the graph, you can see that the starting point is this one here. This one is the starting point of the motion of this ball, and that is the initial velocity of the ball for the entire motion, which is being dropped. That means starting from 0. Now the velocity of the object is 0, of the ball. Remember, the ball is being dropped and therefore it moves downwards. This 10 then, this 10 here is the velocity of the ball at which the ball reaches the ground. So that 10 is the velocity of the ball at which reach the ground. That is the velocity of the ball at which the ball reaches the ground. So all this point here on the graph represent the velocity at which the ball reaches the ground. In this specific question is the same, but not necessarily they are going to be the same. Okay, so in this question is the same and it's 10 meters per second. Okay, so that is the velocity at which the ball reaches the ground. Now what happened? The velocity of the ball changed direction and the balls leave the ground in a bouncing. Okay, so this velocity here, this minus 10, is the velocity at which the ball leaves the ground. Okay, this is the velocity at which the ball, that's right, at which velocity at which the ball leaves the ground. So all this point here will represent the velocity at which the ball leaves the ground. That is important. So the ball is being dropped from 0, a velocity is being dropped from 0 and the ball moved downward. Okay, hits the ground at a velocity equal to 10 meters per second, change direction, bouncing on the ground, with the ground, and then it leaves the ground at the velocity of 10 meters per second. Now, what is important? These points here is when the ball is at the maximum height. That is when the ball is at the point from which it was dropped. Okay, that is important. And this dotted line represents then the bouncing of the ball. All this dotted line here represent the bouncing of the ball. So this ball, in this case, bounced 3 times. Okay, so let's now start with the solution of the equation. Okay, so let's write here a solution. And let's go to question 1.1. Okay, now question 1.1 said what is the velocity of the tennis ball when it hits the ground for the first time. We already answered that one. In this situation, is all the time is going to be this number here for all the bouncing, but they're asking only for the first time. So this is when it hits the ground for the first time and the velocity is 10 meters per second downward. Remember, we're working with a vector quantity. Okay, so the velocity is equal to 10 meters per second down. Okay, remember, velocity is a vector quantity. So this velocity have magnitude and direction. We have to give direction. want to write here direction. We need to give direction as well. Okay, so let's go to question 1.2. How many times did the ball bounce in 6 seconds? So the total times that the ball did bounce was 1 here, 2 and 3. So it bounces 3 times. So 1.2, the answer is 3 times. Okay, let's go to 1.3. Let's go to 1.3. Now, question 1.3 say calculate the height of the building. And if you go to question 1.4, they say calculate the acceleration of the ball. Therefore, we cannot assume that the acceleration is going to be 9,8. No, for this question, because they're asking us to calculate it. Okay, so that data is out of the list. So let's go to question 1.3. They say calculate the height of the building. How high was the building from which the ball was dropped? Now, there are two options to do this question. Option 1. All right, so in option 1, we have to remember, it was done in previous grades, that whenever you have a graph of velocity versus time, the area under the graph will give you the distance. So the area under the velocity versus time graph will give the distance, or in this case, height. Okay, in this case is height. Now, if we go to the graph from here, we may calculate the area under this graph, this side here. This area is clear a triangle, so we can use the area of the triangle. It was work done previously. Then we have one side, then we have the other side. Okay, so the area under that graph will give you the distance. So we come in here, we say that the height is equal to the area of the triangle, which is half the base multiplied by height. If we substitute, we have half, the base is 1 second, the height is 10. Let's make sure, so you can see it there. The base is 1 second, from 0 to 1, this is the base here, this is the height, okay? So 1 times 1 times 10 is 10, divided by 2 is 5. It's 5 meters. This is option 1, okay? Now, let's look at option 2. Let's use option 2. Now, in option 2, we are going to use the formulas, okay? So, as usual, we are going to write first the data, what we have. We have that the initial velocity is equal to 0. We know that the final velocity is equal to 10 meters per second downward. Downward is positive, all the motion is down. In this case, for the first second, the time is 1 second. We cannot use the acceleration because we don't know how much is it. They ask us to calculate it, and they ask to calculate the displacement, which in this case will be the height. Okay, so knowing that one, what of these formulas can we use? So the only formula we can use is this one here. This formula have all the information: the displacement, the final velocity, the initial velocity, and the time. So we come here. Let's do the substitution of the formula first. The displacement is equal to initial velocity plus final velocity divided by 2 multiplied by time. You substitute, initial velocity is 0, final velocity is 10 divided by 2, everything multiplied by the time, which is 1, then 10 plus 0 is 10 divided by 2 is 5, multiplied by 1 is 5 meters. This is the height, displacement. You can see that it's the same in option 1 and in option 2. You can use either way. However, sometimes they ask you to use the graph and not equation of motion. Therefore, in that case, this is the way to go. Okay, so let's go to question 1.3. 4. Question 1.4. Now, question 1.4 is the one that asks about calculating the acceleration. Say calculate the acceleration of the ball. Now, let's also record, say again, from the previous grade you learned that whenever you have a graph of velocity versus time, the gradient, okay, in a graph of velocity versus time, the gradient will give the acceleration. There we go. The gradient will give the acceleration. And from mathematics, you should remember the gradient acceleration is equal to the gradient, which is equal to final y minus initial y divided by final x minus initial x. Sorry, let me just final minus initial, let me just fix this one, minus initial x. So final y is 10, initial is 0, final x is 1, initial is 0. You can go there. You can see here from the graph, this is the final y, this is the initial y, this is the final t, this is the initial t or the initial x. Okay, so here we are. The calculation is 10 divided by 1, which is 10 meters per second square. This is option 1. Okay, let's write here option 1. Write it here. Option 1. Now, option 2 is using the formulas once again. So let's write the data. What do we have now? Again, initial velocity is equal to 0. Final velocity is equal to 10 meters per second. We have the height equal to 5 meters. We have the time equal to 1 second, and we're looking for acceleration. Okay, so what formula can we use? Well, now we have all the information, so actually we can use any of the formula which have acceleration. However, I think this one is easier, so we're going to use that one there. Okay, so it's a final velocity is equal to initial velocity plus acceleration multiplied by time. Okay, the final velocity is 10, the initial velocity is 0, plus acceleration multiplied by time, which is 1. When you solved this small equation, the acceleration is equal to 10 meters per second square. Now, down, we need a direction because the acceleration is a vector quantity. So actually here, we forgot to write it down or downward. Okay, that is the complete answer for that question. I hope it's clear. I hope you understand why it is not 9,8. In this question, they just ask you to calculate it. Okay. Question 1.5. Question 1.5. They ask you if the collision is the first collision of the ball with the floor, elastic or inelastic, and give a reason for your answer. So let's use this opportunity, 1.5, to go through collision very briefly, yeah? But let's record collisions. We have two different types of collisions. Collisions can either be elastic, I use another color here, can be elastic, or can be inelastic. Inelastic. Now, when is a collision elastic? Well, a collision is elastic when the total momentum is constant or conserved, and when total kinetic energy is also constant. So A collision is elastic when total momentum is constant as well as total kinetic energy. A collision is inelastic when the total momentum is constant, but total kinetic energy is not constant. So, what is the difference between the two collisions? In one of them, the total kinetic energy is constant. In the other one, the total kinetic energy is not constant, it's not conserved. So, how do we know if a collision is elastic or inelastic? Well, we need to calculate the total kinetic energy initial of the collision and the total kinetic energy after. Remember, this is just recording. The total kinetic energy is equal to kinetic energy initial of the first object plus the kinetic energy final, plus the kinetic energy initial of the second object. How do we calculate the final kinetic energy? Is the kinetic energy final of the first object plus the kinetic energy final of the second object. So this is how do we calculate the total initial and final kinetic energy. So at the end, if the total kinetic energy is constant, then that means that the total kinetic energy initial must be equal to the total kinetic energy final. You will get the same answer for both of them. If you don't get the same answer, then that means that the collision is inelastic. Now, what is the thing here? In this motion, what are the two objects that are colliding? One of them is the ball, and the other one is the ground. The ground and the ball collide with each other. The ball collides with the ground. All right? The ground is not moving. So the final and the initial velocity of the ground stay constant, equal to 0. Now, the velocity of the ball is the one that have impact in this question. Okay? From the graph, you can see that the speed of the ball when it hits the ground is equal to the speed of the ball when leaving the ground. So the speed of the ball when it hits the ground is this one, which is 10 meters per second. This is speed, only magnitude. And the speed of the ball when leave the ground is this one, which is also 10 meters per second. So the speed is the same with the ground when reach the ground and when leave the ground. Therefore, the collision in this specific question is elastic. So the collision is elastic. That is the answer of the question. I hope it's clear. It is elastic because the kinetic energy is conserved. How do I know the kinetic energy is conserved? Because the speed of the objects stays constant. It did not change. For the ball stay 10 when leave the ground as well as when reach the ground, and the ground does not move. Okay? So that is question 1.5. Let's go to the next question. So question 1.6 say, draw the position time graph for the motion of the tennis ball from the time the ball is dropped until it hits the ground for the second time. So this is when it hits the ground for the first time at this point here, and this is when it hit the ground for the second time. So we'll have to draw the graph up until it hits the ground for the second time, which is there. That is the place where we have to draw the graph. So let's go to draw the graph of position versus time just quickly. Here, this is 1.6. We need the two axes. We need the two axes. Okay, there is the y-axis, which is the position in this case, is meter, and here is the time in second. Okay, so where is the ball initially? It is at the building, which is 5 meters height. This is 5 meters. This is 0, and this also represents the ground. So you must remember the x-axis is like the ground. Okay, so this ball is being dropped and is moving from there to here in 1 second. There it turns around and bounce, so it's going up now. It's going up, it's at the maximum height. The time here is 2 seconds, same height because the collision is being elastic, and it's going down again, hits the ground for the second time. So up until there is the graph they asking. If it's been dropped from 5, go to the ground, which is at 0 level, in 1 second, go to the height again of 5 meters, which is the maximum height, and turn back to the ground and hit the ground for the second time. Remember, this is not showing the whole entire motion, only for the second time which the ball hits the ground. Okay, so this is the question of the bouncing. I hope it did help. I hope you understand. You can ask questions and I'll try to answer your questions. I'll try to make another video on bouncing ball. Thank you very much. Good luck and enjoy the video.